Hi everyone, in this tutorial we work through another example in which we solve a linear differential equation using the integrating factor. We're told to find the general solution of the differential equation that we see here. That is dy dx plus cosine of x times y, which equals to 6x squared times e of negative sine of x. Looking at this equation, we can quickly see that we're dealing with a linear differential equation simply by comparing it to what I would call the standard linear ordinary differential equation. And the fact that we're dealing with a linear differential equation is exactly what tells us, or what should trigger us to, use the integrating factor. That being said, let's see how to solve this. So I'll just write sol as in solution. And just to make sure we can see this equation clearly, I'll quickly copy it in white here. That's dy dx plus cosine of x times y equals to 6x squared times e of negative sine of x. Looking at this equation, the first thing worth pointing out is that there's no function of x multiplying the dy dx. In other words, this equation is written in the form dy dx plus p of x times y equals to q of x. If there were a function multiplying the dy dx, then the first thing we would have to do is divide each side of the equation by that function so that it's written in this form. But in this case, we don't have to do that, and so to solve it, we can follow two steps. The first step, step 1, is to find the integrating factor. So I'll just write that. That's find the integrating factor. We'll usually refer to the integrating factor with capital I of x. And to find it, we use the fact that it's equal to e of the integral of p of x, where p of x is the function multiplying y. So for this example, p of x is cosine of x. And we can state that I of x is equal to e of the integral of cosine of x. Now, since the integral of cosine of x is sine of x, we can go ahead and state that the integrating factor is equal to e of sine of x. Notice here that I'm not writing any constant of integration. And the reason for that is that when we look for an integrating factor, we ignore the constant of integration. That being said, let me quickly box that result. There we go. That's our integrating factor. Now that we have that, we move on to step 2. And in this step, we multiply our differential equation by the integrating factor and use the product rule to solve the equation. So I'll just write multiply d e, as in differential equation, by the integrating factor I of x, and use the product rule. So I'll just write use product rule, and solve. Well, let's see. Multiplying this differential equation by e of sine of x leads to e of sine of x times dy dx plus e of sine of x times cosine of x times y equals to e of sine of x times 6x squared times e of negative sine of x. Looking at the right-hand side of the equation, we notice that this e of sine of x and this e of negative sine of x, when multiplied together, will lead to e of 0, and that's just equal to 1. Consequently, the right-hand side will just be left with 6x squared. So we have e of sine of x times dy dx plus e of sine of x times cosine of x times y equals to 6x squared. And now, looking at the left-hand side of this equation, we can see what the integrating factor is all about. Indeed, we know that e of sine of x is the integrating factor, so that's I of x, and we notice that e of sine of x times cosine of x is the derivative of e of sine of x. And to convince yourselves of that, by all means use the chain rule to differentiate e of sine of x, and you'll obtain this result. So the expression I underlined in green here is in fact di dx. And since I is multiplying dy dx and di dx is multiplying y, we can see that what we're dealing with here is a product rule. And we could write that left-hand side as the derivative with respect to x of e of sine of x times y. And that's equal to 6x squared. Now that that's done, I integrate each side with respect to x, which leads to e of sine of x times y equals to the integral of 6x squared. And that leads to e of sine of x times y equals to 6 over 3 times x raised to the power of 3 plus some constant of integration c. Finally, using the fact that 6 divided by 3 equals to 2, and dividing both sides of this equation by e of sine of x, we obtain the general solution y equals to 2x cubed plus c over e of sine of x. And that's the final answer. We've just found the general solution to this differential equation using the integrating factor. And that's it for this tutorial.